Most people think refrigeration and air conditioning create cold air, but the truth is much simpler and far more interesting. These systems don't create cold, they remove heat. Long before air conditioners existed, people were already using this principle by cooling spaces through evaporation, shade, and airflow without ever realizing the physics behind it. To see this clearly, imagine a simple everyday situation where you step out of a swimming pool on a windy day. As water evaporates from your skin, it absorbs heat from your body, making you feel cold. Without realizing it, you've just experienced the exact principle behind refrigeration. Heat is being removed from one place and released elsewhere. What's actually happening here is straightforward. Heat naturally flows from hot to cold, but refrigeration systems use external work to force heat to move from a cooler region to a warmer one. By continuously absorbing heat indoors and rejecting it outside, air conditioners maintain a lower indoor temperature. This process follows the same thermodynamic laws that govern engines, just in reverse. This same logic operates inside real machines. Refrigerators extract heat from food compartments, air conditioners cool rooms, and industrial chillers regulate temperatures in factories and data centers. The working fluid, called a refrigerant, circulates through compression, condensation, expansion, and evaporation, each step designed to move heat efficiently and safely. The scientific foundation of refrigeration was clarified through the work of Sadi Carnot, whose analysis of heat engines also revealed the limits and reversibility of thermal systems. His insights made it possible to design cooling machines that operate predictably rather than by trial and error. Now that you understand the intuition behind refrigeration and air conditioning, the next natural step is to explore the vapor compression cycle in detail, where we break down compressors, condensers, expansion devices, and evaporators. And that's exactly what we'll cover in the next episode.